Welcome Year 11 students. This video is about the periodic table and looking at how to approach exam questions using deep reading and annotations to maximize the marks that you get. Please remember to subscribe, like, and share this video and the channel to continue to help this channel to grow. Again, I'm not going to read through the exam question approach. I will leave it on the screen for those of you who are new to this channel. If you'd like to find out a little bit more information, you can watch any of the previous videos in this playlist. So looking at question 1, this question is about the periodic table. In 1864, John Newland suggested an arrangement of elements. Figure 1 shows the arrangement Newland suggested. And as I look at that figure, I start to annotate what I notice. Okay, so I can see the non-metals are in group 1 of this diagram. I can see the metals are in group 2, 3, and 4. I can see that groups 5, 6, and 7 are non-metals. So I've just annotated that before I've even looked at part A. Part A says give two differences between column 1 in figure 1 and group 1 in the modern periodic table. Now, in your chemistry paper 1 exam and your chemistry paper 2 exam, you are given a copy of the periodic table. So you will have that to help you, but you do need to know a little bit about it. So I know that group 1 in the modern periodic table is actually full of metals, and it's the alkali metals to be exact, and that's why I have annotated that bit in the question, or in the blurb of the question. The actual question says, use the periodic table to help you give two differences between column 1 and figure 1. So I know that the modern day group 1 consists of metals, not non-metals. That's one main difference. Another difference is fluorine and chlorine are in group 7 of the modern periodic table, not in group 1, as is shown in Newland's table. After checking the mark scheme, I can see that I've got those two right. Now, there is a Revise With Me interactive revision tool that I have done on the periodic table and the key features in it, which you can find on this slide, on this page. Please look at it if you are not aware of the key features of the periodic table. Part B. In 1869, Mendeleev produced his periodic table. Complete the sentence. Choose the answer from the box. So we've got insoluble, doesn't sound like it's relevant to this question. Magnetic, again, doesn't sound like it's relevant to this question. Undiscovered and unreactive. So both of these words are related to the periodic table. So let's have a look. Mendeleev left gaps in his periodic table for elements that were undiscovered. Part C. How are the elements ordered in the modern periodic table? Well, I know that the modern periodic table goes up by atomic number by 1 from left to right, from top to down. So it must be atomic number. And again, checking the mark scheme, they're both correct. Now, these questions, these are low tariff questions. That means they're only 1 mark. They are usually seen in foundation papers, and this is just basic memory recall. So you just need to know the basic facts about the periodic table. So next part D, figure 2 shows part of the modern periodic table, and it's because I've noticed 2 rows at the bottom of the periodic table are missing, but we don't need to worry about that. And I've started annotating the periodic table that's left in the figure 2. So I've labeled the groups, group 1 to 0. I've labeled the transition metal block, and I've drawn a zigzag separating the metals from the non-metals. It says part D, complete the sentences about the elements in figure 2. Choose the answers from the box. So I've got letters A, D, E, G, and J. And it says sodium is an alkali metal, which I know is in group 1, and it is represented by the letter must be D. An element in group 3 is represented by the letter E, because I've labeled group 3. A gaseous non-metal, so it must be on the right hand side, and the only one that's left is A, is represented by the letter A. And again, very easy, got all those marks. And then lastly, we've got part E and F. Part E, figure 3 shows the electronic structure of an atom. So it could be any atom. I noticed straight away that there are 2 electrons in the first shell and 8 in the second, so I can write the electronic configuration as 2 8. Then it says this element is in the shaded group on figure 2, which is basically the noble gases. And it says, why is this element unreactive? And it is in group 0, which is noble gases. And these have a full outer shell of electrons. That's why they're unreactive. And then it says for part F, name the group. Well, I've just jumped the gun. It's noble gases. So again, getting full marks. Now, what you will notice is this question is 9 marks, and I have spent well under half the time answering these low tariff questions, even with all my annotations. Even though I'm reading through them with you, showing you what I'm doing, my thought process, I'm able to answer all the questions well within the time allocated. Now, let's look at question 2. There is no examiner's report for question 1, but let's look at question 2. This question is about sodium and chlorine. Figure 1 shows the positions of sodium and chlorine in the periodic table. And again, I've started to write down the electronic configurations looking at the periodic table. So I can see that sodium is in group 3. So it must have 3 electron shells. And it's, period 3. So it must have 3 electron shells. And it is in group 1. So it must have 1 electron in its outermost shell. So the electron configuration is 2, 8, 1. And chlorine is in the same period, so it must also have 3 electron shells, but it is in group 7, so the outermost electron shell must have only 7 electrons. So part A says state one difference and one similarity in the electronic structure of sodium and of chlorine. So the difference is sodium has 1 electron in its outermost shell, whereas chlorine has 7. And the similarity is they both have 3 electron shells. And again, both of those marks are completely right. For part B, sodium atoms react with chlorine atoms to produce sodium chloride. Describe what happens when a sodium atom reacts with a chlorine atom. Write about electron transfer in your answer. Now, I've answered this question twice. I'm showing you the description in sentences first, but that wasn't the first way I had answered it. I'd actually answered it using a diagram, which I'll show you in a moment. But sodium atom loses its outermost electron to chlorine. The chlorine atom accepts the electron, and the sodium atom becomes a +1 ion, and the chlorine atom becomes a -1 ion. These oppositely charged ions are attracted to each other by an electrostatic force, and this is called an ionic bond to form sodium chloride. And you can see where I've got the 4 marks. 1 mark for talking about sodium loses an electron. Another mark for saying chlorine receives that electron, and another mark for indicating that it's 1 electron. So here's what I first did as a response. So I've just drawn my diagram, and as you can see, it's labeled. I've got a key. I've got the key phrase is talking about electron transfer. So I still get the 4 marks. Okay, so if you've remembered it in diagram form, make sure your diagram is clear, it's labeled, you haven't got any electrons crossing over in the wrong orbit or shell, you should be fine. Okay, part C. The reaction between sodium and chlorine is an exothermic reaction. So straight away, I know that it loses energy to the surroundings, and I make a note of that because obviously that's a clue. Complete the reaction profile for the reaction between sodium and chlorine. So if it's losing energy to the surroundings, the reactants must have less energy. The products must have less energy than the reactants. So that line will be lower. And I know there's a hump in between, so I just connect the lines. I've labeled everything that I can remember, the energy change, the activation energy. And when I check the mark scheme, I'm only getting marks for the fact that the product line is lower than the reactant line and that I have joined it with a hump. So those are the 2 marks that I get. And now looking at the examiner's report for foundation, because this question was seen on both the foundation and the higher tier paper. Part A, this question discriminated well with 27% of students achieving some degree of credit. Many students did not consider the most obvious difference in similarity in the electronic structures of sodium and chlorine. Students often use the periodic table shown in the stem of the question to answer this question, but most of these students refer to periods or rows and groups or columns and so failed to gain any marks. Part B. This question discriminated well. 23% of students achieved all full marks, often with concise statements about the transfer of the outer electron of sodium to chlorine. Some students contradicted their description by mentioning covalent bonding or the sharing of electrons, which restricted the number of marks they could attain. Poor expression and the use of incorrect terms were the main problem for most students, so it's so important to use the correct terminology. It was common to see the term atom used instead of electron. 19% of students did not attempt to answer this question, so they just didn't have the knowledge to answer it. Part C. This question discriminated well. 26% of students achieved both marks, whereas 185 of students achieved a single mark. It was common for students to have incomplete reaction profile diagrams by failing to include a horizontal line for the products. Okay, so they weren't familiar with the reaction profile diagrams. Some students confused the two types of energy changes, endothermic and exothermic, while others provided a wide range of incorrect diagrams. Labels were ignored because they were not required to answer the question. 20% of students did not attempt to answer this question, so 1 in 5 students did not attempt. Higher students, Part A, 73% of students achieved at least a mark on this question. Many could clearly see the most obvious difference and similarity in the electronic structures of sodium and chlorine. These correct answers were described in a variety of ways, for example, the different number of electrons, or by stating the correct number of electrons in the outer shell. Examples of similarities related to the number of shells or completed inner energy levels. Students often use the periodic table shown in the stem of the question to answer the question, but most of these refer to periods and groups and fail to gain the marks, so just like the foundation paper. Students should note that there is only one outer shell or level. Part B. This question was well answered, with 63% of students achieving all full marks, often with concise statements. Some students contradicted their description by mentioning covalent, the incorrect type of bonding, or the sharing of electrons, which restricted the number of marks they could attain. And remember, in the question, they actually said, talk about electron transfer. So you shouldn't be talking about sharing electrons at all. Students need to use scientific terminology accurately. So this statement again, ionic bonding occurs when a metal transfers its electrons to a non-metal. So it's the loss and gain of electrons, or in other words, electron exchange or electron transfer. Whereas covalent bonding involves nonmetals sharing electrons, which results in the formation of covalent bonds. So you really need to know the difference between those two. And again, in my Revise With Me series, I've done an interactive revision tool looking at the differences between the different types of substances: ionic, covalent, simple covalent, giant covalent, and so on. And some of the differences are based on how the atoms inside those substances are bonded together, or ions are bonded together. And I mention and look at, for example, the fact that ionic bonded substances have ionic bonds where electrons are exchanged, and covalent substances, the electrons are shared. Again, you can access that video using the link. Part C, 67% of students achieved both marks, although it was common for students to have incomplete diagrams by failing to include a horizontal for the product side. Some students confused the two types of energy changes, endothermic and exothermic, while others provided a range of incorrect diagrams. Question 3. This question is about the halogen, so already straight away I'm thinking group 7, therefore they have 7 electrons in their outermost shell. Part A. Write the state symbol for chlorine at room temperature. I know chlorine is a non-metal, and it's a non-metal that's a gas at room temperature. So I write lowercase g. Then part B says the diagram below represents one molecule of fluorine, which I know is another halogen. Can complete the dot and cross diagram on the diagram above. You should show only the electrons in the outer shells. So they've drawn one electron in each shell, and they've given me a cross in one and a circle or dot in the other. So I know that it's in group 7. okay, because it's a halogen. So it must have 7 electrons and it must share one with the other fluorine in order to have 8 stable in its outermost shell. So all I do is I draw 6 more electrons, making sure that one of them is in the overlap of the electron shell with the other fluorine, and I do the same but with dots instead of crosses. And again, I get a mark for part A, got that right. And for part B, the marks are awarded for making sure that there is a pair of electrons within the overlap and that there are 6 electrons drawn in on each fluorine atom, remembering that one is already drawn in for me, making it 7 in total. Part C, a fluorine atom can be represented as shown. And already I've highlighted the fact that the smaller number is the atomic number, which equals the number of protons, which is the same as the number of electrons in an atom. So it says, what is the total number of electrons in a fluorine molecule? So in a fluorine molecule, F2, it must be 9 plus 9, which will be 18. And then part D, aluminium, which I know is in group 5, reacts with bromine, which I know is in group 7, based on the periodic table that I've been given. But actually, I don't have one in front of me, but I just know that from memory, to produce aluminium bromide. Complete the balanced chemical equation for this reaction. So this question is actually a question found on a higher paper. So foundation students, you might find this a little bit difficult. But what I remember when writing ionic formulae is that the charges, so if aluminium is in group 5 and it's a metal, it forms a +3 ion, and bromine or bromide ions, they are in group 7, so they form a -1 ion. So all I have to do is take the numbers of the charges, and they are going to be the subscript numbers for the opposing ion. So the -1, the 1 charge, goes as the subscript for the aluminium ion, and the 3 in the 3 plus ion becomes the subscript of the bromide ion. So I end up with AlBr3 as the chemical formula for aluminium bromide. Once I've done that, I can then balance the rest of the equation, and I can see that I need 3 bromine molecules making 6 atoms to equal the 6 bromine ions that are in aluminium bromide, and 2 aluminium atoms to equal the 2 aluminium ions in aluminium bromide. Part E. When chlorine reacts with potassium bromide, chlorine displaces bromine, and they've shown me the equation. Then it says, explain why chlorine is more reactive than bromine. So straight away, I've started to annotate what I remember in the periodic table. Now you will be given one, so you wouldn't necessarily need to write fluorine, chlorine, bromine, but I have added the electron configuration. So 2, 7 for fluorine, because it's got 2 electron shells being in period 2 and 7 in the outermost shell being in group 7. Chlorine is 2, 8, 7. And bromine is 2887. And I know that fluorine is the most reactive in group 7 and the least reactive as you go down the group. So chlorine has 3 shells of electrons. The outermost shell needs just 1 electron to be stable. However, bromine has 4 electron shells. This means it is harder for an electron to enter its outermost shell because of the electron shielding of the electron shells. The outermost shell is also further away from the positive nucleus, so less attracted to the outermost shell of bromine compared with chlorine. And when I've checked the mark scheme, I'm getting marks for the fact that I recognize that chlorine has less shells than bromine, or has a smaller diameter, if you like. That it's harder for an electron to enter the outermost shell, and I've mentioned electron shielding for the 3 marks. Now, for the examiner's report for part A, students did not answer this question as well as expected. They were either not aware that chlorine was a gas or were not familiar with state symbols as answers other than S, L, G, or AQ were frequently seen. Some wrote the word gas in the space. 36% of students answered correctly. Part B. This question was very well answered, with 64% of students achieving full marks. Students showed a good understanding of the number of electrons involved in this example of covalent bonding by ensuring that they had 2 electrons in the overlap area and 6 other electrons in the energy level of each fluorine. A common mistake was to include 2 electrons in the overlap, but still included the 7 electrons each fluorine originally contained in the level outside the overlap. Remember, you need 7 in total. C, 48% of students selected the correct answer to this question. The question followed the diagram of a fluorine molecule in part B and focused on this species. A significant number of students incorrectly selected 9 as their response, which is the number of electrons in one fluorine atom. Part D, students are expected to represent the electronic structures of the first 20 elements of the periodic table and to predict and explain the reactions of elements from their position in the periodic table. So you need to be familiar with the first 20 elements. A small number of students were able to state the correct formula, AlBr3, with AlBr and AlBr2 being the most common incorrect formulae. But students did show a good understanding of balancing equations. In this case, based upon their wrong formula for aluminium bromide, 68% of students achieved a single mark. So they carry the error forward, if you like. Part E, this question was not answered well, with 8% of students achieving 3 marks for the explanation that included comparative size of atoms, comparative difference in attraction, and the ease of which an electron was gained. This last point was the one that was least seen, and the word outer shell or level was omitted in a lot of answers. So you need to talk about outermost shell. Often students would repeat the question stem in terms of chlorine and bromine's reactivity without relating it to the whole of group 7, and in many instances referring to the reactivity series of metals. So we've had a look at another 3 set of questions in or from the chemistry paper 1 topics based on the advanced information. I will continue to do this for the next few days. I think it's going to be quite important looking at practice questions from the chemistry paper 1 topic, because most of the revision tools I've shown on the Revise With Me channel. So please check that out if you are still trying to, practice your retrieval and memory of those topics. But I will continue looking at all the other topics in chemistry paper 1 because they're not leaving any topics out. So please subscribe, like, and share this video. Remember to do your revision in small, intense chunks so that you're better able to work effectively. And I wish you all the best and good luck. Bye.